Hi everyone, welcome back. In this video, I'm going to talk about Python, programs, scalar objects, expressions, variables and values, and simple operations. Python is a general purpose interpreted and high-level programming language. It was developed around 1980s, and then it was derived from other languages like C, C++, ABC, and so on. You can actually read a lot about Python in the Python documents, so you can check it online. So why do we use Python? Why Python? Because you can run Python code by using just a browser. You don't have to install anything. You just go to Python Anywhere or Google Colab and then write your Python code, run it, and it will give you an output. It runs on their server. So that's how easy to use. That's how easy it is to use. And let's say we have this example hello user, instead of the usual hello world sample. I want to use this hello user example to have a more bigger picture of different languages. So in C, this is how you code it. This is the implementation of this hello user problem in C. You will see printf, scanf, a lot of percent symbol, and so on. In C++, it will look like this. How many lines? 10 lines of code. And C out, C in, so on. Here, this is Java. Okay, so there are classes. And then in Python, it will look like this. Beautiful, isn't it? So Python is is an easy language for beginners, I think. It's closer to human language. That's why it's a good language to start with. So here you will see printing to the console. You just you use this print method. Okay, so yeah, this is the reason why we are going to use Python in this class. A Python program is a sequence of definitions and commands. Definitions are evaluated, and the commands are instruct the interpreter to do something, or the instructs Python to do something. A Python program can be typed directly in a shell or stored in a file that is read into the shell and evaluated. Okay, so you can type your code in the shell, or if it's long enough, you can write it in a file, in a text file, and then eventually run it into the shell. Okay. So in Python, everything is an object. Okay. So and objects have a type that defines the kind of operations that we can do, or the program can do to them. For example, I am a human, so I can walk and speak English, and etc. Read, etc. So, for example, another example is Snoopy is a dog, so he can walk, bark, etc. Okay, so yeah, and then in Python, there are basically two types of objects: scalar and non-scalar. Scalar cannot be subdivided, and non-scalar have internal structure that can be accessed. For example, the number 5 is a scalar, and a list of numbers is non-scalar, because a list of numbers has elements, and an element is a number that the program or that Python can access. Scalar objects in Python are the following. Integers, int for integers, for example, the number 5, the integer 5. Float for real numbers, for example, 3.27. Bool for Boolean values that may have values true or false. The non-type, which is a special type and it has a value none. And there is a command in Python which is type that we can use to see the type or to know the type of an object. For example, here type inside the parenthesis, we put the integer 5. This is what you write into the Python shell. So by the way, this 3 greater than sign or greater than symbols, this one means the Python shell. And the output is int. So it means that the type of the object 5 is int, which is integer. So this int will show, or the output will show after hitting the enter. Type conversions are cast in Python. By the way, in my lecture, I will introduce concepts by giving the algorithm first before the specific syntax for Python, like in this example. So if the algorithm for the concept is applicable, I'm going to show it to you. So hopefully this will help you differentiate the algorithm part from the syntax which is specific to the language, to Python, and hopefully this will help you in learning your second programming language. So here, for example, type conversion. The type conversion algorithm is this one. So let's say we have this object, old type data. So this one is a data type that has type old type. And then another object, new type data, which is a data of type new type. So the algorithm to convert this type is convert old type data to new type data. And how do we convert this, or how do we translate it to Python code, is using this syntax. So the type conversion in Python is you can convert object of one type to another using this syntax data type, and then inside parentheses you have the object. For example, float. Inside the parenthesis, you have the integer 3. So this one converts the integer 3 to float 3.0. In the second example, we have int 3.9, and this one truncates the float 3.9 to integer 3. Take note that type conversion does not round off. It truncates the decimal part. So how do we output a message to the user via printing to console? So the algorithm for output is this one. Let's say we have a message, which is the text to write to the user, and then the algorithm is output the text message, wherein the message is the text that you want to show to the user. So in Python, to show output from code to a user, we use the print command. And the syntax for the print command is this one. Print, and inside the parenthesis, you have the message. For example, here, print, and then you have the text or the string hello world. And this will output hello world. Then print, inside it is the object, the number 3 or the integer 3, and it will output this 3. to the user, to the console. So expressions, if you can remember, I mentioned expression in my previous video, and expressions is like phrases in English. So expression, the algorithm is combine objects or data and operators to form expressions. So that's expression in any programming language. In Python, the syntax for a simple expression is this one. You have an object, operator, and object. The expression evaluates to a value. And since it's a value, it has a type. So an expression eventually will evaluate to a value of a specific type. Here are some operators on ints and floats. We have addition, subtraction, and multiplication. For this three, if both operands are integers, the result is an integer. If either or both operands are float, the result will be a float. For the division, the result will always be a float. And then we have the percent here. This one outputs the remainder when I is divided by j. This percent is the modulo operator. And then the asterisk here in the last example is I to the power of j. Parentheses in Python are used to tell which of the operations will be evaluated first. So that's the use of parentheses. And in most programming languages, that's also the case. In case there are no parentheses, the operator are evaluated, or here is the precedence of the operator. Highest one, the one with the highest precedence is the power, asterisk, asterisk, then the multiplication, and then the division. And addition and subtraction are evaluated from left to right if they appear in the same expression. So a new variable, how do we create a new variable? Here is the algorithm for a new variable. This one, again, I will emphasize this is a general algorithm. We have name. So this one is what we want to call this thing or this variable, whatever it is. And then the type. So what type of data does it contain? This is the type. And then the init val, what is its starting value? So the algorithm for creating a new variable is this one. Create a variable named type of type that starts with a value, init val. Okay, so this one is the general algorithm. Take note, there are languages that will not require an initial value, but will require a type. Okay, so like in C, and there are programming languages that won't require a type, but would require an initial value upon creation of the variable. So, for example, Python. Okay, so this one, since we already know, or we have this algorithm to create a new variable, we can translate this into code of a programming language following the syntax of a particular programming language. In Python and in almost all programming languages, the equal sign is an assignment operator. It assigns a value to a variable name In this example, we have pi, the variable name pi, and the value 3.14159. The value 3.14159 is a float, is an object of type float, and it is stored in the computer memory, and an assignment binds the name pi to the value 3.14159. It means that this value pi, we could use it. We could by invoking the name pi or by typing the name pi, we retrieve the associated value to the name or to the variable name pi. In the second example, pi underscore approx equals 22/7. The 22 is divided by 7, and the answer to this expression is assigned or is bound to the variable name pi underscore approx. We give names to values of expressions to be able to reuse the names instead of values or instead of long expressions. It's easier to change the code later on if we would have to just change the one line of code, which is let's say, which is assigned to the variable to a variable name, instead of changing several expressions which are the same, and then and refer to the same value or the same object. And in programming, we have to remember that we do not solve for x. The equal symbol is an assignment operator, and it means that the expression on the right-hand side evaluates to a value, and the value that value is assigned to the variable name on the left-hand side. Therefore, if we see an equal symbol within the source code or within the code, it means that the right-hand side is an expression which eventually evaluates a value, and the left-hand side should be a variable name. So in this example, this expression is also equivalent to radius equals radius plus 1. And this line of code is a comment in Python. All characters after the hash symbol and up to the end of the physical line are part of a comment. It means the Python interpreter will skip this line, will not do anything with this line of code. In Python, and again in almost all programming languages, we can rebind variable names using new assignment statements. Let's say we have here pi equals 3.14. This means that the value 3.14, which is an object in Python and of type float, is bound to the variable name pi. So here pi binds to 3.14. And then the name radius binds to 2.2. And here the third line, we have area equals pi asterisk inside parenthesis radius double star 2 and closed parenthesis. So this means that this has to be evaluated, and then the value will be assigned to area, to the variable name area. we get the value of pi. We go to pi and see the value that it binds to. So it's 3.14 times radius. The radius is 2.2 to the second power. And this expression, after plugging in the values for pi and radius, this expression evaluates to 15.1976. And then this value is assigned to area. Thus, area now binds to 15.1976. And then the fourth line is radius equals radius plus 1. This means we increment radius by 1. And in the computer memory, this creates another object, which is of type float also, and the value is 3.2. And radius now binds to 3.2 instead of 2.2. The handle of the radius to 2.2 is removed or is crossed out, and radius now binds to 3.2. Take note that 2.2, the object 2.2 is still there in the computer memory, and at some point the garbage collector may remove that the value in the memory. And then also take note that the value of area, or the name area, the variable name area, still binds to 15.1976 even if we change the value for radius here. The value for area does not change until we tell the computer to do the calculation again. That's all for today, and I hope you enjoyed our lesson today, and have a nice day.